Very good morning to all of you. Welcome to this webinar conducted by Mel Systems and Services here in Chennai. My name is Balaji, and I'm the HOD for the sales and marketing for the automation and Industry 4.0 division. So, without further ado, let's jump into this presentation, and I'll be sharing that here. I hope all of you can see the screen. If any of you have any issues, just you can say it out loud. Okay. Let's jump right in. Welcome to this webinar. This is being conducted today by me. I'm Balaji Rajan. I head the sales and marketing for automation and industry 4.0 here at Mel Systems and Services Limited in Chennai. Just a brief background on Mel's. Mel Systems was started back in 1995. We are a very well-known company for our engineering and technology solutions. We have about a 200 plus employee count. We've completed about 2,000 plus projects, and our presence is across 20 plus countries. We have our head office here in Chennai with our main branch offices in Bangalore, Mumbai, Delhi, and Kolkata. And we do have sales and support and service engineer support in places like Chandigarh, Ahmedabad, Aurangabad, Pune, and Secunderabad. So this is a brief overview on Mel's and our system and structure. We've been around for about 30 odd years now, and quite well known in the industry for our automation solutions and engineering and technology solutions with the highest quality and technology levels. Let's jump right in. The topic for the day is the hidden factory, unlocking 20 to 30% efficiency without new machines. This presentation, is going to focus on discovery, qualification, and the art of transformation, what I call the art of transformation. This is eligible for both external sales and business development teams, looking to develop their business with other companies, and also internal project teams within companies who are looking to transform their operations and manufacturing systems. Now, typically, companies are having to ask questions of, do we need to buy new machines? Do we need to add CapEx? So the first question to ask is, are we first using 100% of what we have? And the simple answer is most plants aren't. And there is a much larger capacity gap than we know or understand. Let's understand how to figure this out. Now, with the concept of OEE, most plants today are, this is the base problem. Most plants today are running anywhere between 60 to 70%. And I would say based on the type of company, whether it's a large scale company or an MSME and the type of industry, this OEE can broadly vary anywhere between 40% to even 75 to 80%, right? The world-class OEE is 85%. That's the benchmark for top performing plants. Maybe a pharmaceutical company might have a world-class OEE of only 70%, right? So it also depends on the industry and the domain in which we are working. But typically, within the India context, MSME companies or SME companies are working with OEE somewhere in the range of 45 to 55%. If you are in the 60 to 70%, maybe you are within the slightly higher range. Now, what is the hidden factory, right? I mentioned that let's explore the hidden factory. What is it that we mean by hidden factory? Where does unrealized capacity that I'm talking about actually come from, right? And this is typically buried across 4 loss categories that, most plants are not tracking regularly or don't know how to track. And they typically fall under these 4 categories. It's unplanned downtime, where equipment stops are not tracked or logged, or they are not understood in real time. Unrecorded minutes or downtime is lost, and that's revenue that cannot be recovered, right? Now, it can be in the form of quality defects and rework, and typically units that consume machine time, but they don't produce any saleable output. They just go into your rejection or contribute towards your cost of poor quality. This is cost consumed with no output. So this is rework, basically is what we call a parallel factory. right? Then we have speed losses, basically machines that are running slower or in slower or with less than their rated capacity. And this can be due to multiple reasons. It can be due to wear and tear or incorrect settings, or even just operators not knowing how to operate the machine correctly. Now, these are all invisible factors, but they are relentless in the sense that they're always there, they're invisible, and they're always detrimental to your operations. And of course, the fourth one is your changeover inefficiency, basically excess setup time between production run. There can be maybe a large 30-minute changeover between your lines or products that are causing unrecoverable loss of man hours. So these are all categories of where your hidden factory lies. Now we can even call these the six big losses. There are further breakdowns of each of these individuals headings, which I'm not getting into, but you can typically track all these under what we call the six big losses, right? So this is where the hidden factory lies, and this is where these are the headings under which we need to start understanding where we are losing out. Now, what happens is the challenge is very simple. So the root cause of hidden inefficiency is actually the invisibility, right? Or rather, I would say the fragmented visibility of the information across the shop floor. Basically, your systems don't talk to each other, and if they're not talking to each other, the plant cannot learn from itself. Basically, if there's data not being shared between different systems, different departments, then you cannot learn from each other and you cannot make any improvements. So what does a fragmented system look like, right? Let's go through this. On the left-hand side, we say before, which is fragmented. Basically, your MES, ERP, and SCADA system don't talk to each other. They're all standing independent of each other, operating independently. Now, operators are logging issues on paper or spreadsheet, but that data is already stale by the time it is reviewed and any action can be taken on it. Now, decisions are made days or hours after the event, and they're typically reactive and not proactive. And there is no single source of truth for line performance. So every shift, every operator is telling you a different story because of the data that is being logged, tracked, and analyzed on a delayed basis. So this is what we call a fragmented system. This is the before system. Now, what is after? What is your North Star? What is it that you would want to aim towards? Is to have a connected shop floor. And what is a connected shop floor? It's basically a unified data layer across all the machines and systems, basically giving you one version of the truth. It doesn't matter what operator is working, which machine it is, which shift. The data is being collected online, inline, and on time, and being analyzed on time to give you one version of the truth. Basically, real-time events are being captured at the source. There's no manual entry, no lag. The alerts and insights are delivered in seconds, and you can act on these alerts before the losses start to compound. And every operator sees the same live dashboard. So you can collect all the information, but you can also present it back to the operators in the line who are working with the system, and they can then align themselves with the floor or the directions given to them in terms of production output, right? So this is what we would call a fragmented system, and this is what was an after system, which is the connected shop floor. Now, like I said, the basis for all this, understanding the health of our shop floor, our operations, our manufacturing, is all encapsulated within this one terminology, the OEE, or what we call our overall equipment effectiveness. It's a common terminology that everybody knows. Basically, everybody within operations knows. And if you don't know, please get to know this. This is your best friend. It's basically a simple formula. It's availability into performance into quality. And these three parameters capture basically your entire performance across your shop floor. It's a single most powerful metric, and it is very useful for exposing your hidden factory. And it is the starting point for every improvement initiative. Just to give you a big brief background, what is availability for people who don't know? People who already know, please bear with me. For the people who don't know, let me just go through quickly what it is. Availability is what is the percentage of planned production time and was the machine actually running, And downtime is the planned and unplanned. And this is what destroys the metric. The unplanned downtime is what destroys this metric. And you typically want to have at least a 90% target for this availability. What is performant? Performance is basically, is your machine running at full rated speed and capacity? So if your speed or capacity is reducing because of losses in wear and tear, your settings are wrong, or your operators are not operating it correctly, then your throughput reduces. And here again, your target should be at greater than 95%. And finally, of course, quality. What is the quality of the units being produced, right? How many first pass yield? That is, how many times is a product running through the system coming out correctly within just the first attempt? It doesn't have to go back in through the parallel factory and run again through a second or third operation to get it to meet quality requirements. This is your quality. So this again should be at closer to 99%. And the product of all these three is your OEE. Like I mentioned, your industry average can run anywhere between 45 to 70% for MNCs, and it can be lower for smaller SMEs with lower digital maturity, having maybe about 35 to 55%. And this low number, the 35 to 50%, is the gap is the hidden factory. This is what I am talking about. And typically, MNCs have a larger digital maturities and smaller SMEs have lower digital maturity. And to build this capability is the basis of unearthing your hidden factory. Now, you can get data from the OEE. You can identify where your problems are, and we will get into more details as we go forward. But how do we then, this is the digital aspect of it. The gathering the data for OEE and understanding your performance is the digital aspect of it. Now, there is a physical automation stack also. And the physical automation stack can encompass what I'm showing below, right? These are typically electromechanical technologies that can attack the waste directly in the plant. And they can attack a specific category of OEE loss. And what are these electromechanical technologies? They fall under, these are not all inclusive. These are some of the technologies. I'm sure there are more out there, but these are some of the more important ones that we use out there for automation. There are industrial robots, which we are all familiar with. They're high speed and high precision arms. You've got cobos or collaborative robots that are capable of working safely alongside humans. You have vision systems, which are AI powered cameras, which are providing for inspection of 100% of parts inline. You've got smart conveyors. These are sensor equipped conveyors with variable speed control and routing logics. You've got smart actuators and IIoT, which is your industrial Internet of Things products. Basically, these are server drives, smart PLCs, and edge connected sensors that can stream machine state data directly from the shop floor, right? And these are typically very useful for providing you even product or part level information, right? And finally, of course, you have AMRs or autonomous mobile robots, which provide for routing of materials dynamically throughout your shop floor or warehouse. So this is what we call your physical automation stack. You have your digital and your physical automation stack. And typically, a combination of both these categories is what is utilized in the shop floor to improve our OEE and unearth the hidden factory. Now, each technology that we've shown before, the physical technology attacks a waste category separately, right? And this is a very important slide. And if you can absorb this and understand this well, it'll go a long way towards helping you in your conversations within your company or external to your company when you're talking to other people to understand what their problems are and what the ultimate solutions to their problems are, right? Let's look at it. We are mapping here very simply the technology versus the OEE parameters. So you need to deploy the right tool at the right loss category so that the solution is based on the data, right? So let's look at this technology. We've got industrial robots. These industrial robots are very useful for attacking availability. Basically, they are capable of running 24/7 and they have no fatigue stoppages. If you have problems in performance, you can use industrial robots. They're always running at rated speed and there is no pace variation. So in your OEE, if you're having problems with availability and performance, you can use industrial robots to attack these two categories. Do industrial robots, really provide that much towards quality? In this case, no. They definitely do in the long run, but they're not a direct contributor towards improvement in quality. That's what this tabular column indicates. Let's look at the next technology, cobos. Now, how do cobos affect with you in terms of availability? They cut changeover time by about 40 to 60%. So availability of the machines go up. Performance of the also goes up because you now have consistent cycle times and you can eliminate operator variance, right? Let's look at the next technology, which is vision systems. Vision systems directly attack any issues related to quality. Now they can catch 99.9%. Okay, there might be a little bit of variation in that, but for the sake of this argument, let's say they can catch 99.9% of defects in line, and which means there is going to be zero rework. Your cost of poor quality comes down, and your parallel factory, what we call your parallel factory, also comes down. So vision systems can directly help you improve your quality metrics. What do AMRs do? AMRs can help with improving, again, your availability. They eliminate material starvation at cells. And from a performance perspective, they provide for continuous flow and no idle or wait time between the runs, right? Smart conveyors, again, they help with availability and performance. Smart conveyors can provide prediction on jams. They would say, okay, hey, you have materials coming in from multiple directions, converging towards a single point, and smart conveyors can do traffic management to help you avoid those jams, right? And help you avoid those stoppages, line stoppages. And they can also, from a performance perspective, they can do auto pacing, or basically the same traffic management. They can route and speed up or slow down the line based on the takt time and based on the traffic that it is projecting ahead of its position. So there is no manual adjustment. There is no lag in that sort of a process. And of course, we are looking at IIoT and smart actuators. It's right at the bottom of this list. But let me tell you, this IIoT and smart actuators form the basis or the fundamental foundation for most of the improvements that you will implement in the shop floor. They provide for improvements in availability. Basically, they can provide predictive maintenance alerts in real time. They can improve your performance. Basically, they're providing real-time speed and state monitoring. Basically, these are physical conditions that can be monitored using these sensors. And they also provide for improvement in quality. Basically, your process parameter deviations and alerts can be projected using these actuators and IIoT sensors. So these sensors and actuators form the foundation of any of the improvements that you are planning for your operations. So like I mentioned, this is an important tabular column. Please do keep this in mind for any of your improvements that you are looking to implement. It'll cut down on a lot of waste of time and also help you focus your activities in the right place and the right time. Now, what is the first step in an OEE process is to find the real bottleneck. And you use the real-time analytics to do this. So your line is running at the speed. Okay, so we all know that the bottleneck forms the speed at which your entire line runs. So the slowest operation is the speed of your total line. So you can use real-time OEE analytics to pinpoint exactly where the slowdown is happening. So you don't have to guess. You can get actual data and identify the station where this process is slow, and then fix the right place at the right time, right? So this is just an example. You can see this image over here. We have station 1, station 2, station 3, and 4, and 5. And using our OEE metrics, which we have implemented, we have realized that station 3 is your bottleneck because it has a 64% throughput, or maybe a 64% availability, or 64% loss in quality, whatever it is. It's a bottleneck. Now, painting is what limits your entire line's production. And this has been identified through data received from your OEE analytics, right? And that's, if I was to summarize what we are doing through OEE, we are first sensing. Basically, we are using your IoT sensors to stream machine data every second. There is no manual data entry, there is no shift end delays. You're not having people entering data at the end of the shift. So this is all real-time data. So you're sensing using the sensors. You're analyzing the data. It could be AI, it could be simple SPC-related information. And you're identifying the constraint which is causing the queue or buildup of the upstream activities. And you're also able to quantify the hourly cost, right? So this is very critical. And then you're able to what is called surface the problems. Basically, you're able to create dashboards and reports to management and your operations team that showcase what is happening. So these dashboards will, show the actual root cause. They will downtime, what are the downtime codes, what are the speed ratios, what are the defect types. And these are all in plain language that every operator can understand in real time as the issue is happening so that they can take action immediately. And that is the most critical aspect of this. All this has to be done in real time. And OEE helps us to do this, very well. So this is your analytics. Now, basically, like I mentioned, the Industry 4.0 toolkit consists of these four basic categories. And I just mentioned this in the previous slides also. There are four integrated layers, what we call our digital layer, which is driving our physical automation. Okay. And each layer is feeding the next. Each layer is feeding the next layer of process so that it can take do an analysis. It can then provide the input to the physical automation. So you've got it. Your data informs the analytics. Analytics directs the automation, and the automation triggers the action. So here we call it the connect, the IIoT or the edge sensors, which can be through your protocols like OPC UA and MQTT. Integration is happening. You've got smart conveyor telemetry that is coming in, or maybe you have unified machine data layer. All these are the data or connect that is happening at the shop floor level, at the machine level. This is then analyzed. This is where you have your real-time OEE dashboards, and maybe you have artificial intelligence or machine learning, software that is detecting these anomalies. You might even have simulators. You have digital twin simulations that are happening today that can, provide for live bottleneck identifications. You can then, this analysis then provides the inputs to what is the automation you need to implement. So maybe you need to do, based on my previous slide, you would remember, you could maybe based on the analysis, where your loss category lies. And now you might want to do robos and cobos or put in an AMR or maybe a combination of the two. Maybe for your quality gateway to improve, you want to put some vision guided sensors. And maybe you want to create the entire closed loop with all this to ensure that there is no leakage of data or poor quality items. And finally, of course, once you have these systems in place, you have to act and implement the automation. Once you've identified what you want to automate, how do you want to automate, you now act on it, you implement it on the shop floor. Now, you implement it with feedback. Basically, this automation also starts to give you alerts. Now, maybe these alerts and data that it is collecting might also give you predictive maintenance scheduling. Maybe there are parameters on your machines which you are tracking, which is allowing you to dictate or understand, hey, this machine is going to break down maybe another 2 weeks because I have a vibration level sensor which is giving me this data, and at this data level, this machine is going to break down in another 2 weeks. So these sort of things can be predicted, and you can have predictive maintenance schedules, and you can have closed loop corrective actions which can be triggered instantly. So this is critical. These four steps are critical in how the entire digital system and the physical automation loop form a closed loop and allow you to, again, the basis of this entire presentation, how to unearth the hidden factory by identifying your loss categories, your issues and your problems in real time, and directing the correct automation, the physical automation stack or analysis aimed at the problem to solve the solution. To provide the solution. Now, it might seem, logical, but some people do ask, okay, so what is this? Why both automation and digital intelligence should it be? Can't I just do OEE and that should be enough? Or let me just do automation. I know I have a problem with throughput. Let me just input or quality. Let me just input a vision system, or let me just input install a robo or a cobo, and I'll solve my problem. It's not that simple. There are economies of scale that can be, if I was to use simpler technology, there is a compounding effect of utilizing both these things together. The digital intelligence that comes through the OE analysis and the physical automation work together to give you a compounded output, which is better than utilizing each of these individual solutions separately, right? So if I was to implement just a digital only, you might get maybe a 10 to 15% OEE gain. Yes, today you have dashboards and now your analytics are revealing the waste. Yes, you are able to do that. But then you still have humans who will be executing it very slowly, and there will be variation between different humans who are implementing it differently. So you have the insight, but without the correct action, the output is limited and it has a ceiling. What happens if I do only the automation? I put in only the vision systems, or I put in only the robos. Yes, I might get maybe even a 12 to 18% OEE gain, right? Now the robos and AMRs are running very fast, but they are running blind. They are running without attacking the problem at the correct place at the correct time. Without data, they cannot self-correct and they cannot adapt to different conditions that exist on the shop floor. And without being able to adapt, they cannot continuously improve. So your solution is fixed in time. You might be able to put in a robo or kobo, but it's fixed in time, solving a problem only for that specific period. And without data to complement it, it cannot continuously improve itself and improve. So that we arrive at our final, which is the digital plus the automation, implement the OEE, identify the places where you want to improve, analyze, identify which automation you want, physical automation you want to put, and then put it in. Now, this gives you analytics drives the robotics, or the vision drives the quality loops. The AMR's response to live demand. You have a closed loop, and it is self-improving. And this is what unlocks your hidden factory. This automation plus digital intelligence implemented together is what unlocks the hidden factory. And this seems intuitive, right? But we find, and Mel's is a company that has been working for quite a few years in this implementation of automation. We find that many customers are, are reluctant to get into both, maybe due to it could be budgetary, it could be time, it could be multiple other constraints. But typically we find people who say, no, let's just do the OEE. Okay, let's stop with that. Or I know what I want. Give me a robo, put a kobo here. But that's not how it works. And this is the reason is this slide. So the best in class result is always is the hidden factory. It is always fully unlocked only when the intelligent digital systems guide the intelligent physical machines in a continuous feedback loop. This is very critical. Right. So I've spoken quite a bit about, how we approach what it is that we do. Let's look at a simple case study here. This is not an Indian context. I've given you maybe an American context here. But again, this is an SME company, and I maybe focus a little bit on the SME companies because their data and digital maturity might be lower, their automation maturity might be lower, and really the ability to unlock this hidden factory is higher in some of these SME companies. So let's take a case study of this SME company. This is a company that's based out of Ohio, and they were making sheet metal fabrication as a tier 2 vendor into automotive business. They were a small SME company, like I said, somewhere between 50 to 200 employees. Here I'm taking a very specific case of a UR10 Kobo that was installed. How did they do it? Before, they identified that, they had their CNC and welding cells were a constraint for them. They had an OEE of about 52%. If you take the baseline, they are having welding throughput of say 1x, that is the baseline. And their CNC machine utilization was about 32%. And they were only doing the day shift. Now, they needed operators are needed across 4 cells. So they needed 4 welding operators across these 4 cells. And the defect and rework rate was almost 3.8%, right? And that's pretty high. And they couldn't do any lights out production. That is, there was no night shift capability involved because maybe they weren't able to get labor, maybe they weren't able to get manpower to come in and staff those kind of night shifts. So an OEE analysis would give you this data. That is the before data. It's telling you where your problems are. It's telling you about your OE output. It's telling you what your throughput is. It's telling you what your defect rework and rework rate is. Now, what is the after? So once the issues were analyzed and we were able to give the UR10 Kobos, right? These were implemented, and the solution implemented immediately saw an output improvement in OE up to 84%, from 52 to it went up to 84%. Now in the welding throughput, from a 1x it went to a 4x. That was the improvement. The utilization for the CNC machine went up to almost 90% over a 24-hour period, down from 32% to almost 90%, which is a significant increase. The operators needed went down from 4 to 2. They were able to run on all 4 cells with just 2 operators. The defect and rework rate went from 3.8% down to 0.7%. And they were also able to implement 24-hour production, maybe even across the 3 shifts. So they were also able to do lights out production. So what does it mean for an SME company? So the first question they ask is, hey, this is great. They were able to get all this output improvement. But what did it cost? What was the investment? Well, the output of this can be measured using the ROI, the return on investment, and this was delivered within 12 months for this solution, which is very aggressive, considering most companies are looking at ROI of around 18 months. This is an aggressive ROI of around 12 months, and we find that when you implement digital plus physical automation together, the OE plus physical automation, you can easily get ROI anywhere between 6 months to 12 months. This is use case scenarios have been understood, and 6 months to 12 months is a very doable ROI for many of these cases, especially important for an SME company, right? So these are some of the numbers. These are some of the numbers that came out through the case studies. And again, let me reiterate. This is for an SME companies, and typically SME companies have a lot of gap, and a lot of improvement can be realized at very good ROI by implementing such plant transformations as I've shown over here. And this is not the only way. This is just one case study. And like I said, there are multiple technologies that can be implemented for various loss categories and improvement situations. And the ROI can be calculated for each of these situations. So what's the roadmap? So you've seen what it is, what can be done. And let me tell you, this roadmap is the same whether it's a large MNC company or whether it is a small scale company. This roadmap is the same. It's a very practical 3-phase implementation path that you can follow. You first start digital. You need to start collecting data. You need to start doing data logging to get your information in real time. Let the data tell you where to automate. Then you deploy the physical automation, and you deploy it exactly where it has to have the highest return. So the first one is to sense. What we call the phase 1 is what we call the sense and see. This you can do between months 0 to 3, right? Where you deploy the IIoT sensors and edge boxes or edge gateways and all the lines. You connect all the MES, ERP, and SCADA data to create a single unified data layer. You launch your live OEE dashboard for every operator, or it could even be a consolidated OEE at a central monitoring location. But you should have an OEE collecting all this data. And you use this OEE data to identify the top 3 bottlenecks with data, not on opinion, not on feeling, but on what the data is actually showing you. So this is the sense and see phase. The second phase is what we call the automate the bottleneck. This can be done between the months 3 to 9. You deploy the Kobo or Robo at the identified constraint station. You install the vision systems. Maybe this could be something you do. Install maybe a vision system on the highest defect rate step. I'm just giving you different automations that you could maybe implement. Or maybe you deploy AMRs for total top material flow routes. Wherever you have the routes with the maximum material flow, you maybe implement AMRs. And finally, you also validate the OEE lift. What is the baseline? What is the target? And what is it is currently? So is there an improvement, and what is the improving? So you do this line by line for wherever you have identified these issues. And finally, what we call the scale and close the loop between months 9 through 18. This is phase 3. So now, once you've done it for the top 3 categories or top 3 bottlenecks, you now roll out the automation to the remaining lines using the phase 2 playbook, right? That is using the same process that you used for phase 2. In phase 3, so you roll out the automation to the remaining lines. You enable, maybe now you start to enable predictive maintenance, because now you're collecting data. Now you're collecting inputs. You can use all this data now to start doing predictive maintenance for all your connected assets. You now can activate a closed loop quality control, and you can even start doing automated work orders or automated corrective loops. So where you don't need manual intervention. As soon as the data crops up, there is a system that logs the data and triggers a corrective action automatically. And you can do a full plant digital twin operation, continuous improvement mode. Basically, you can create the digital twin. These are simulation softwares. You can create a complete digital twin because you now have the data. You now have some of the technology. You can implement that in a simulation. Offline or online, you can see problems that are happening. Offline, you can implement solutions, see whether the problem is solved, and then implement the problem in the solution in the shop floor. This is a great asset. The digital twin is a great asset. You can utilize simulation because you can simulate solutions to your problems offline without having to spend the money in buying a Kobo or buying a Robo. You can simulate it using the digital twin, see if it works, and then spend the money in actually buying the solution. So these digital twins are now turning out to be great assets for evaluating whether the solutions you are going to implement are worth it or not. So this is a practical three-phase implementation path or a roadmap that any company can utilize in their systems, right? Now, let me take a little bit of a deviation. I was telling you about how to identify the hidden factory, what are the the technology involved, how do you do it, how do you unearth? But there's a step that happens even before this, and this is applicable whether you're sales and marketing or a business development executive in an automation company looking to work with another company or a manufacturing company. This holds true also if you are whether a plant head or an operations head or an engineering head or a lean practitioner within an organization who's getting started on the transformation process for within your own company. Because let me tell you, even within your own company, you're going to have hurdles. You're going to have conversations with decision makers where you have to show or convince or prove that what you are doing is correct and whether the path that you're taking is correct, right? So the next few slides is going to take you through how do you run this process? How do you start the conversations? What are the questions you ask? And how do you do this process of transformation within your own company? Or if you're a sales and business development executive or a lean practitioner for other companies, right? So the best entry point to start is to identify a specific operational plane. Now, typically, if you're external people or internal people, you're obviously working with your plant directors or your operations head. It could be a CTO, it could be a CEO, it can be a CFO, it doesn't matter. You have to answer to these people when you say, hey, listen, there is a specific operational pain that I want to address, right? But you also need to be able to speak the language. It can be takt time, it could be throughput, it could be OE, it could be cost of port quality, it could be in terms of SPC, but you need to be able to speak the language of the shop floor. And you should be able to challenge the current situation or the status quo with evidence. There's no use just saying, hey, listen, I know maybe this is happening. No, this is the data. I have seen it happening. So the status quo has to be challenged with data, right? So lead with the technology, lead with the OE, not the technology. Don't say, listen, I'm going to look at implementing a robo. The question is why? So lead with the OE. So all the current slides, the previous slides that I have shown you lead you towards this conversation. So when you start conversations with these people, start with lead with the OE. Open with what's your current OE? What is our current OE? Do we know what the top 3 loss categories are? Do we know it by line? Okay. And if they don't know, or if we don't know, that's exactly where we've established the opportunity to start. Then typically there's always also the capex assumption, right? There's always, the beginning of the year or the budgets are being discussed, and already you're talking about allocation of, capex or capital expenditure, investments, and money towards implementing some solution. But even before we start talking about whether we are using 100% capacity of what is installed. That is where we need to start. That is the hidden factory, whether we are utilizing that, can we unearth that even before we start the capex decisions, right? Discussions. So this reframes. It doesn't become a strategy. It doesn't become a budget conversation. It doesn't become about approving money and capex, but it starts to position you whether you're internal or external as a strategic advisor, and this is very critical going forward to drive the drive these transformation initiatives within an organization or in other external organization. Third, of course, is to quantify the hidden factory in the currency of what it is that the person you're talking to. Maybe what does 1 hour of unplanned downtime cost you? Then multiply that by the average downtime into hours per week. Maybe it tells you this is the cost of the hidden factory. Then use the case study as a mirror. What I have shown you as a case study. You can show that as a example. Why do you show this? Maybe there are issues that companies are facing that they identify with. When you show a case study, they'll say, hey, listen, yeah, that's exactly what I'm facing. That's exactly what I'm going through. And when they identify you solve the first hurdle of convincing a person that yes, this is applicable to the current situation. So use case studies to highlight or unearth cases where the person is identifying with the problem. So this is how you start conversations or open conversations. Like I said, this is very critical. I want to reiterate, this is everything that I'm saying here is applicable whether you're internal to the company, whether you're trying to do automation within your own company, or whether you're an external sales and business development executive in an automation or system integrator trying to do automation implementation within other companies. Now, these are all questions. And like I said, there are decision makers at the senior most levels, your C-level executives, etc. We're going to be asking you questions about why you're doing what you're doing. And I'm just highlighting here some of the questions that come up, right? In our experience, we have done this quite a bit, and these are some of the things that come up. And you also need to be asking the right questions towards the right people, right? This is also very critical. Please know that at the right level, you can't ask the same question at the operations level or the operator level as the CEO or CFO. They'll be thinking about completely different things than from the operator level. So OEE and capacity questions could be anything. Is what's your current OEE by line, right? If you could add 25% throughput without new equipment, where would that capacity go? Towards your orders, margins, or both? How often are you running at full rated speed across every station? What was your worst downtime? What was your event? Did it happen last quarter, this quarter? And how long did it take to diagnose your root cause? These are all questions that, a good manager or an operation head should know in order to run their operations well. It might be an operations manager, it could be at the operator level, it could be at the CTO level. It can be at any level, but these are information that people need to know. And only if they know this, can you be confident that they are running their operations well. If they don't know, so that is OE and capacity questions, right? Maybe you have data and visibility questions. Okay, when a line goes down, how quickly do you know and through what system? Does your MES, ERP, and SCADA system share data in real time? And does someone reconcile them manually? How do your operators currently log downtime events? And how confident are you in the accuracy of the data? Can you tell me right now, without leaving this room, which station is your production bottleneck? So these are all powerful questions. These are all questions that need to be asked. And if you're finding that there are no responses or the responses are poor, whether you're, again, I repeat, whether you're internal to the organization or whether external driving this, these are important questions, and the responses to this will tell you where the health of the existing system. Okay, and it will help you to guide in your conversations towards directing plant heads, CEOs, CFOs, or your operations managers towards implementing these transformations. Now, typically you will start off, there are two types of conversations you can have, and only one guarantees a strategic win, basically. So when you're into industrial automation, the first conversation that everybody will ask you is typically equipment selling. Everybody's like, I want to put in a robo, I want to put in a cobo, and you're always talking about the equipment. The question is, can your robo weld this joint? Can your system improve this? Can your system equipment help me with this? Now, that decision and that buyer and that problem is at a very different level, right? Whereas the transformation that you're selling is a very different question. The question is, at the highest level is, can you reduce my unplanned downtime by 30%? I am not talking about equipment. I am not talking about selling a product. I'm talking about the transformation. Can you reduce my unplanned downtime by 30%? Or I can reduce your unplanned downtime by 30%. This is the conversation starter for transformation. right? This is where we need to start. And these are the decisions that, are taken typically at the CXO or the plant director levels. The buyers, the people who are making decisions on these investments are typically at the CEO or head of manufacturing levels. We have evaluations that are being done at the business case and ROI proof levels, right? We have key variables: transformation, credibility. We've got these variables are critical, right? The transformation credibility comes from asking the right questions and providing the right solutions, right? The relationship is that you're coming in as a long-term solution provider. Now, whether you're internal or external, all transformation happens over the long term. Yes, you do have short-term improvements, but if you're not able to show credibility over a long term, this is not going to work. No CEO or CFO will ever accept something that's, okay, this will give me improvement over the 3 months, 6 months. That's it. Okay, what is the long-term improvement that is going to offer? That's what we're all looking at. And cycles are typically 6 to 18 months. And we are looking at a multi-phase program. Like I told you, phase 1, phase 2, phase 3. Implement small first, extend it out to automation, then parallelly across to other lines. Right? And so at the highest level, to drive this transformation, talking about transformation and implementing and driving the transformation are two very different things. And to drive and ensure that this happens, the three things you have to take into every transformation is understand the outcome, not the technology, build the business case before the proposal, and to position yourself as the person who's going to be your partner in the long term, right? Whether you're an operations or lean practitioner within the organization or an external business development executive, you are here for the long term to provide a solution, not a short term equipment manufacturer seller, right? So that's the most important thing that we look at. Now, here's the discovery process. There are the 5 conversations before the proposal. The proposal is the very last thing, right? So these are some of the things that you should ask before you get into the proposal process. It is called the discovery, and discovery is not an interrogation. It is a structured sequence of conversation that builds the business case collaboratively with the customer, right? And the customer can be internal or external. That's the point. And the question is that these are some of the questions that you can do. Where are the losing production time, quality, or visibility today? What does leadership expect from manufacturing next 3 years? Have you tried to solve this before? What happened? What would success look like 12 months after implementation? And who else needs to be part of this transformation and decision? And what do they need to see? So these are all important questions that need to be answered. If you need to have great discovery, that is, how do you unearth and ask the right questions to make sure that you're drilling down to the root cause and root problem, addressed at the right person, right people, right time. This is very critical, right? So you're fixing across operational pain, you're fixing across the strategic context, you're taking into account past attempts and history so that you don't repeat the same mistakes. You define what success is going to look like, and you understand what the decision-making process is. This way, you don't waste time, money, and you don't waste people's effort. Okay, so you don't lead with the solution. Stop leading with the solution, and you start leading with the problem. And the business case is built during the discovery, and you don't work with the proposal first. You always build the business case, build the discovery, and then only build the proposal. Right? So the discovery walk is a very, very important part of the structured exercise. You need to do a pre-walk briefing work. It can be, with the plant head, it can be with the operations manager, it can be with the operator. Spend 15 minutes before the shop floor walk, what we call the shop floor discovery walk. Understand what you're going to see. Go station by station, observe, spend about 60 minutes on this. You will note, things like actual versus rated cycle times. What are the visible idle times? Are there manual material being moved? Is there any paper-based logging that is happening? And also, are there any operators who are moving around and walking around? These are all fingerprints of a hidden factory. Then talk to the operators, speak to them, understand their problems, understand their issues. What slows you down most on a typical shift? What problem do you report every week that never gets fixed? Operators know what their losses are, so you should speak to them to get real-time information and data. Finally, of course, get back, spend about 25 minutes to debrief and map of what the gap is. This is very critical, where you put everything together, you build a simple 2 by 2 map. What is your loss category versus the estimated frequency. And this is a very, very critical step, this mapping, right? When you map the loss category versus the estimated frequency, you show where the actual losses are, and you can drive the aha moment. Oh, okay, this is where the issue is, this is where the problem is. Let's now drive our solution or our implementation towards this problem. Right? And what do you normally look for when you do this discovery walk or the shop floor walk? You look for availability signals. Machines are stopped, operators are waiting, there are long startup or shutdown times, the changeover boards or paper-based sheets are being used, quality signals, rework benches, manual visual inspections, scrap bins that are constantly overflowing, or 100% end of line sampling that is happening instead of 100% inspection. What are the performance signals? Maybe there are machines that are running slower than normal. Maybe operators are manually pacing up and down the line, looking at where the buffers are. Maybe there's WIP piling up at a certain stage, or maybe you're seeing and there is no input at this thing. There's manual starvation. And there is also data and visibility signals. There are paper being shifted from location to location. There is no live production data. Supervisors are making rounds to gather data, or you have no real-time OE or takt time information. So these are all signals that can be tracked. The objection handling, we will come back to. This is, I will skip this slide because the objection handling I've already taken in the previous slide. These will come up, and I've already highlighted how to address that with the discovery process. But do note, you will hear things like, we've tried automation before and it didn't work. We don't have capital budget for this right now. My operators won't accept Cobos on the floor. We can't afford disrupting production schedules. So these are all things which can be avoided by going through the discovery process that I have mentioned already. Right. So, and my final slide here is Mel's can help you with all of the above. We are into this for many, many decades now. Your next capacity expansion is existing within your plant. We can help you. The tools to unlock it, both digital and physical, exist today. And Mel's has all these capabilities in-house. The intelligence to unlock them is here. The only question is, how much longer will you leave it hidden? Do you want to, do it right now? Mel's can help you unlock this hidden factory. Reach out to us today. We will help you with the scope of work. What is it that we will do? We will help you audit your processes. Okay, measure OE and map the data. We will help you even implement the OE. We have our own software. We have our own inbuilt software and data. We have software systems. We have software engineers who can do this work for you. We can identify and map your bottlenecks and pinpoint the actual issues. We can do this digitally and precisely. And finally, we can implement and pilot your deployment automation at the constraint sectors. So Mel's is capable of working with you at all levels, whether it's instrumentation, control, electromechanical, software, or the IIoT and edge networking. We have capabilities to do all this with you. So please do reach out to Mel's, and we'll be very happy to work with you over the long term to help you unearth your hidden factory and to help you unearth the hidden capacity that you have within your existing plant today. Thank you so much for your time and for spending your valuable time listening to me here today. I'm open to questions that you may have. We have about 5 to 6 minutes, and I'm open to any questions that the audience has. Please feel free to raise them here. Right. I'm not seeing any questions coming up. If you have, you can please raise your hands too. That's also you click the button and raise your hands, and I'm happy to answer any questions that you have. Okay. If there are no questions, I'm not seeing any questions. Moderators, are you seeing anything in the chat? Okay. I'm not seeing any questions. So I think I'll end this webinar by thanking everybody for joining here today. I really appreciate that you took the time here to attend, and I encourage you to reach out to us at MELS, and we can definitely help you with your implementation and transformation journey. And we look forward to working with you going forward. Thank you all, and have a great day ahead.